Welcome to our explainer. Today, we are diving deep into the science of flight, a force of nature that has totally changed our world. Let's get right into it. Really think about it for a second. Have you ever looked out an airplane window and just wondered, how is this massive 400-ton machine defying gravity? It feels like it should be impossible. Well, it's not magic, but it is an absolutely fascinating field of science. And the science that makes it all happen is called aerodynamics. At its heart, it's really just the study of air and how it moves and behaves when objects, like a plane, push through it. It's a huge part of a bigger field you might have heard of called fluid mechanics. And here's the really cool part. It is not just about airplanes. Aerodynamics is the reason a supercar is shaped the way it is, to hug the road. It's how a drone can just hang there, perfectly still in the air. It's even what gives a curveball that wicked break. It's a force that's pretty much always at play. Okay, so to really get how flight works, you have to stop thinking of it as just one thing. Instead, picture this. It's a constant battle, a cosmic tug-of-war between these incredibly powerful invisible forces. And believe it or not, every single object that flies, I don't care if it's a paper airplane or the space shuttle, is being pushed and pulled by exactly 4 fundamental forces. These 4 forces are locked in this constant dynamic struggle for control. First up, you've got the vertical battle. Gravity, which we call weight in this case, is always pulling the aircraft down toward the Earth. Fighting against it is lift, that magical upward force that the wings generate. So to even get off the ground, lift has to be stronger than weight. But at the very same time, you've got the horizontal battle. The engines produce thrust, which pushes the plane forward. But the air doesn't just get out of the way for free, it pushes back. That resistance, that friction, is called drag. For the plane to accelerate or even just keep moving, thrust has to be stronger than drag. It's this beautiful, constant dance. Lift versus weight, and thrust versus drag. So when thrust beats drag and lift beats weight, you get flight. Sounds simple, right? But out of these 4 forces, one of them is the undisputed hero of the story. The one that's truly responsible for conquering gravity itself. And that force is lift. It is, without a doubt, the most critical piece of this entire puzzle. Without lift, a plane is just a very expensive, very heavy piece of metal sitting on a runway. So how do you actually create this invisible upward force seemingly out of thin air? Well, creating lift is kind of like following a recipe. You need 4 key ingredients. You need the speed of the air moving over the wing. You need the density of that air. You need the total surface area of the wings, and, this is the most important part, the special curved shape of the wing, which is called an airfoil. Now, don't let the equation scare you. The main takeaway here isn't the math itself. It's just to show you that all those ingredients are connected in a predictable way. If you increase your speed, you get more lift. If you fly higher, where the air's thinner or less dense, you actually get less lift. It's not some kind of mystery, it's a repeatable scientific principle. But to really get this, we need to zoom in even closer. We need to understand the environment where this all takes place. We have to talk about the nature of air itself. Okay, here's a concept that might bend your brain a little bit. Air is a fluid. Yeah, I know, we think of fluids as liquids like water, but in physics, a fluid is just anything that flows. And air definitely flows. Once you start thinking of air as a fluid, everything about how it moves around an object starts to make sense. And because air is a fluid, it can flow in 2 main ways. On one hand, you can have this beautiful, smooth, orderly flow called laminar flow. That's super efficient. On the other hand, you can have chaotic, messy, swirling, turbulent flow. The whole art of aerodynamic design is about managing this flow, trying to get as much of that smooth, laminar flow as possible to make things more efficient. Now, here's where it gets even cooler. The rules of how air behaves don't just stay the same. As you start moving faster, and I mean way faster, the physics begins to change in some really dramatic ways. You see, aerodynamics isn't a one-size-fits-all kind of thing. We actually classify it by speed using something called the Mach number. Mach 1 is the speed of sound, so the commercial jets you fly on, they're subsonic, flying well below Mach 1. As you get close to that sound barrier, you hit the transonic range, where shockwaves start forming. And once you break through it, you're supersonic. And then at the crazy speeds of spacecraft and missiles, you're in the hypersonic realm. Each stage plays by its own set of rules. To put that into perspective for you, a regular Boeing 737 cruises at about 80% of the speed of sound, so it's firmly subsonic. But then you had the legendary Concorde. That plane was built to live in a completely different physical world. It was a supersonic jet, literally outrunning the sound it was making as it sliced through the sky. Okay, so we've gone from the four basic forces to the fluid nature of air, all the way to the spectrum of speed. But why does any of this matter to you? Well, because these exact principles are at play all around us, every single day. The sleek shape of a modern car? That is pure aerodynamics, all designed to reduce drag and save you gas. A wind turbine? That's basically just an airplane wing stuck on a pole using lift to generate clean electricity. Drones rely on these principles for every single tiny movement. Even in sports, that incredible curve on a free kick in soccer or the swing of a cricket ball, it's all thanks to the way air flows around a spinning object. So you see, what starts as a simple tug-of-war between four forces becomes a science that has completely defined the modern age. It's what lets us fly around the globe in a matter of hours and generate clean energy from the wind. It's a fundamental force of nature that we've learned to harness. Which, of course, leads to the ultimate question. Now that we understand the rules of the air, what's the next great frontier?